Okay. All right. Well, everyone, we're going to go ahead and get started here. We have an hour to talk to you. We want to try to get a bunch of information to you as much as possible. On the line, you have Ryan Cole. I will be the Solidworks person showing you what's going on. And then also joining us is Mark Jewell. He's with ExactFlat. And we'll both be working together to kind of bring you up to date on best practices for furniture makers and kind of moving forward into the future as well, too. So we're going to go ahead and this will be a mixture of a little bit of just presentation, but we'll also be doing some demonstration as well too. And with that being said, obviously this is a program, so hopefully we won't have any incongruencies during the thing here. So what we're doing really is I'm going to hand this over to Mark here and let him kind of bring you up to speed a little bit on what we're trying to bring across for you. Mark, would you like to go ahead?
Excellent. Thanks very much, Ryan, and welcome everyone. Thanks for joining the webinar today. I hope you find it informative. As Ryan said, we're going to go through a little bit of a demonstration, kind of show you how things are being done now and what we see as the future of furniture manufacturing, and how we're seeing a lot of furniture manufacturers now making the move to digital. And the key benefits to that are basically design flexibility, being able to create your furniture parametrically so you can make changes on the fly. Cross-team communication. So what we see, ExactFlat and Solidworks is kind of the hub for the enterprise. So we can create our bill of materials, we can create our frames, we can create our fabric, we can send all this information out to different ERP systems, PLM systems, we can send our information to cutting machines, we can do our costing on the fly. So there's a huge benefit here for time savings and costs, of course. I'll go to the next slide here, which is what we say integration is key. And what we mean by that is one team creates the frame, one team defines the cushions, and changes are missed in manufacturing due to the constraints of the system. What Ryan's going to show you, what we're going to show you today is basically how we bring everything together to work as a unit, as a single unit. And I think that's a very exciting concept and one that I hope you can appreciate. So Ryan, I guess without further ado, I'll leave it to you.
Sounds good. Thanks. So go ahead and mute yourself and get some, sip some water or something there, get some hot tea. So we have, we want to kind of look at three main broad ideas here. So we have our design, we have our production preparation, and then we have our integration of hard and soft goods. And this is going to be where it never has been highly integrated. And we want to kind of show you that integration as it goes through here. So the integrated digital workflow, when we go digital, when we go 3D, really what we're looking at is kind of a main thoroughfare of how the information is going to cross through. Ultimately, we're looking at the linking and shrinking of the entire system. You're not going to have it spread out over a wide area. You're going to have it really streamlined, and it's going to be able to move back and forth. It'll be bi-directional in the way that it can move around. And when we look at this digital patterning workflow, we're really looking at the design aspect. How are you designing today? What can you do? 3D CAD is an obvious solution, but we also have other ways to do stuff as well too. You can have laser scan stuff, you can digitize information today, and then you can also do a parametric template, which kind of allows you to create families of parts very easily and very quickly, and then have that downstream effect as being quick and as well. The other one is, the customization. Being able to modify items is going to be a pretty big deal here. The first design may not be the best one. Your customer may not like that design. Something may need to change to encompass, different situations. And this is where the 3D design can really help you. You can go in and make those changes, but then the downstream effects, once again, are all streamlined. Any changes that you're doing at this level is also automatically populating downstream levels as well too. When you get done with that, usually we'd have to have somebody go out and whether it's with paper or test fabric and trying to flatten stuff out. And really we're looking for an optimization when we get here. So what we're going to do is we're going to add in the cut lines, show what the pattern looks like, and then do the conversion from 3D to 2D and show that once again it's all connected with everything above it. So there's that bi-directional thinking there. Once we get that together, we have the pattern, you're adding your seams, you're putting the nest and the marker together, you're maybe getting cost estimates, and then you're also getting a bill of materials, something that maybe you don't do today, only because it's a lot of extra overhead that might have to go through. But now today, you can just do it with a click of a button. So really what it comes down to is when you get to the end of it, you can print it, you can code it, you can sew it. And this is that linking and shrinking of the entire process that we're talking about here. So let's go ahead and, we're trying to get rid of waste. We're trying to get rid of waiting. If you have a streamline, changes aren't the end of the world. Corrections aren't the end of the world. And what you'll find is when you do streamline the process, your corrections of errors at the end of the process seem to kind of disappear at that point. So let's get into a little bit of a demonstration here. And bring up a chair. And this is a chair that was designed in Solidworks. We take a look at it. We've got a couple of different pieces and parts that are in here. We can see that we have some areas that we want to fabric up, but let's talk about the design aspect, especially when you get into the Solidworks side of things. So I got a little, I've got this piece here that we want to kind of take a look at. And what I want to show you is when we talk about ease of design and ease of use of the system, and then also making those changes, this is what it really gets into. So if I come in and I create something new, I'm going to go ahead and go and just create simple shapes. The simple shape in this particular case is a rectangle if I'm taking a look at that cross beam there. On top of that, we have the ability to kind of, test things out. What does it look if it's thinner? What if it's taller? What if it's skinnier? Whatever's going on here. But once we kind of get comfortable with something that is in there and what shape it is, we can go ahead and start adding our numbers in. So as we add these in, you'll see that the geometry kind of comes together, starts working for us, and it'll stretch as needed. Now what we're doing here is what we call parametric modeling. It means that we don't draw the geometry specifically to the right shape. You draw the general shape and then you add dimensions on later. The beauty of it is that if you need to make a change, you simply change the number and it's going to update the geometry on the screen for you automatically. We're going to go ahead and go back to 3 inches here and we'll do an update on it. And then we'll go ahead and take this and start taking that 2D shape and turn it into a 3-dimensional model. Fairly straightforward here. Once you get it in, you can go ahead and just grab whatever you need to, and you can kind of see, once again, you can see everything that's going to happen beforehand. So we're going to go ahead and let me go ahead and just make that, we'll just make it 3/4 inch thick at this point in time. Also, if we take a look at this, when I say okay to that, we now have a nice little block on the screen. I know it looks simple, but simple is really how you get things done. We don't have to worry about the super complex shapes because we can go ahead and just take little bits and pieces here and add stuff or subtract stuff as needed. One of the other things that we had to take a look at here is the fact that I will go ahead and create a little bit more geometry. There's a little bit of a dip in the middle of that so that we have the place for the seat to sit onto. So we'll go ahead and add that in. Now, along with this is what we're doing is, like I said, it's called parametric modeling. So I'm going to go ahead and add in a couple of little lines here. And when we talk about parametric, we're really talking about making something smart. Right now, if I take this and try to move it around, it doesn't stay centralized for me, and that's not going to work very well later on if I have to do some changes. So just to make sure I don't have to worry about this, I'm going to go ahead and make these little lines equal to each other. That means that as I move on one side, you'll see that the other side is automatically updating with it. And then once we get it acting correctly, we can go ahead and throw some more dimensions in here to kind of shore everything up. So we can say that that's 1.5 inches from the end. We can come in and say that we want to control the actual dip here. So we'll go ahead and say that's 1/2 inch. And then when we get done with it, once again, we get back into 3D. And then we can go ahead and tell SOLIDWORKS that we want to cut that little scarf out there. So you can see that we're starting to build a shape and get it together here. Last thing I'll do is I'll throw some tendons in here. So I'm going to go ahead and grab the end. And then once again, use those simple shapes. So we'll add in a size here. And then we'll give it an overall length of 1. And that's going to give me some good tendon geometry to work with. And once again, as we spoke before, it's always this back and forth. You're into 2D, then you're into 3D, and then you're back into 2D, and you're back into 3D. So it kind of allows you to finish up what you need to, kind of see what's going on there, and then finish up whatever else we need to go with. So in this case, I'm going to go ahead and throw some fillets on here just to make them nice and rounded. I can pick all the edges manually if I really wanted to, but SOLIDWORKS offers us a lot of tools to be able to quickly add information in. Once again, type in what we're looking for, and then it adds it in there for you. I have to add another tenon on the other side. Why would I go through all the work here when I have a set of tools that allows me to quickly go through and reuse geometry that I've already created here? So we'll go ahead and grab everything we need. We'll say okay to that. And then when I zoom back out again, we'll see that we have that on the other side as well too. The only other thing I might want to do is kind of shore this up a little bit. I don't like the hard corners in there, so we'll go ahead and put a nice big radius on here. Once again, we're getting feedback instantaneously as far as what it looks like, and then we can continue on working with this to shore it up a little bit more. So with just a couple of steps here, we're able to go ahead and add in all the information required. And we have a part that looks pretty good here. The only other thing I might want to do is I might want to tell it that it is a piece of wood. Depends on what you're working with. If you're working with tubing, if you're working with wood, or whatever it may be, we're going to have some materials in here that are going to be able to work for you. So in this case, let's go ahead and just make it a mahogany. And what this will do in the long run is, because we're working with solid models, it's going to give us the ability to do a lot of downstream processes, whether it's a stress analysis to see if this is going to be strong enough, whether it's packaging, how much does this weigh? Along with the cost of the wood, you can check the volume of it and figure out what the cost of it may be. You may check the linear lengths of it. So there's going to be information that you might not have available before, especially if you're just doing 2D, or you're kind of just guessing and kind of making the furniture organically. The last thing I want to do here is, while I have some dimensions in here, I'm looking at these tenons, and the tenons don't look like they're long enough. So I'm going to go ahead and simply double click on them and say, hey, look, I need you to be 1.5 inches long. So, 15 probably wouldn't work out. Let's do 1.5. So once I make that change, I can go ahead and look at some other items here. Let's see. I think this dip is not quite deep enough. We're going to go ahead and make it a 1-inch dip there. And then even here, let's go ahead and scoot this back. So what you're seeing here is I'm making lots of changes to the part, but quickly I'm able to see what those changes will look like in the end. So it works pretty well for me in the long run. Once I get this done, I do have my 3D part. And really what I need to do is I need to be able to communicate this to somebody else. Someone's going to have to cut this out. I might have router information that I need to send out. So an ideal way to do that would be to go ahead and create this as, say, a 2D drawing. Now, we put a lot of work into this, so let's go ahead and make sure that we don't waste the work that we put into it. So I'm going to come in and do one other item here. We're going to go ahead and use something that we call DIM Expert. What it allows me to do is to quickly add manufacturing information to the print itself, and let's go ahead and say okay to that. Now you can set this up for your company, so if you are worrying about tolerances and stuff like that, it's going to be pretty straightforward to set it up. But basically what we've done there is been able to apply manufacturing dimensions without really putting too much work into it, and without having to reinvent the wheel and do extra work in the long run as well too. So once I create that, I'm going to go ahead and say I need the 2D drawing. 2D drawing should be fairly straightforward. And what I'm going to do is I'm going to say that as I create the 2D drawing, I want Solidworks to help me put the information into the drawing as well too. So I'm going to tell it to go ahead and bring in those dimensions. As I pop these down, we can go ahead and see that as I just drop them, it will go ahead and throw those dimensions in that I had on the part. And even here, we can add in an isometric just to make it look a little bit nicer. Now, even though this is a traditional, or looks like a traditional 2D drawing, we do have a lot of benefits here that we may not have had before, especially when we get into anything like scaling or showing, better information on the screen itself. The only thing you really have to do at this point is, if there's any time being spent here, is going through and just ensuring that the dimensions look good, they're in an appropriate place, they make sense, and kind of go from there. So we'll go ahead and say that those look good there. And this would be probably what I would call the fidgeting around with it, once again, just to go ahead and put that information out so that the guys on the floor or the people on the floor can make the part a little bit better. So maybe spend another 5-10 more minutes with this. You're going to be all set with it. And really what it comes down to is the fact that if I were to make changes here, I think that dip is a little too much anymore. So we can come back and we can always make the modifications as required. So let's go ahead and make that 0.75, 0.745. And then we'll go ahead and update the model. we'll see that the model's been updated. And when I go back to my drawing, I don't have to make any changes to it. The changes have already occurred here at this time, and all I need to do is reprint it out. So no loss of time, no double checking. If everything was done correctly to begin with, it's going to work forever after that. The only other thing we might get into is the fact that we do have assemblies. As you're building the parts, you're going to put these parts together, much like Legos in certain cases, and there's some more advanced functionalities that you can get into later on as you get more comfortable with the software. But one of the key benefits that we do have here is the fact that if I don't like something, well, I can go ahead and make a change to it. So let me come in and take a look at this. And while I look at this, I realize that this may be a little bit too short. Maybe we looked at it, it looks like it needs to be a little bit longer. Well, just like we were making changes at the part level, we can make the changes here at the assembly level as well too when it's all put together. Say I want to take this from 2 inches to 3 inches. I go ahead and double click on it. I tell Solidworks to do a rebuild, and we can see that pretty quickly here. There it is. It will update it on the screen for me. So I don't have to make a change to a part, update the drawing, and then come into the assembly and go, oh, but it's not right here, and I have to make this change. Everything will be interconnected together, and everything is file referenced to each other as well, too. So once again, going back into it, making changes is pretty easy. It's on the fly, and we don't need to worry about too much more after that. Along with that, you can get a bill of material out of here as well too. So if you're looking at how many pieces do you need, what do you have to go with, what kind of hardware do you need if you want to put hardware in, that can all be inclusive into your assemblies. And then when you put your assemblies into a drawing, you do have that capability as well too. So it is a full-blown CAD system. It should have everything it is required to create your actual engineered data, if anything. So going through it there, obviously I'm going full power here, but really the walkthrough, less than 30 minutes. We created the 3D for the hard design for the soft components. Let's go ahead and go back a little bit here for more demonstration. And in this particular case, let's go ahead and take a look at how ExactFlat goes into this whole process here. So let's get this part. So in this particular case, we've got our floor back, or the back of the seat here. And at this point, what we want to do is we want to bring the ExactFlat tools into the system here. So Mark, I was wondering if you wanted to kind of talk to everybody as we walk through this process.
Sure, I can do that. Can you hear me?
Yes, I can. We can all hear you here.
Good. So basically what Ryan's going to do is he's going to use a create piece tool.
Create the seams first.
Oh, he's going to create the seams first. All right.
There you go.
All right. Now we have a seam.
Sorry about that. So yeah, what we're going to do here is I'm going to create these seams real quick, and then we can let Mark kind of kick in here. But really identifying those seams, this is going to be where the communications between the departments come together as well too. So if you have a technical pattern maker, they can come in and either advise or even take over at this point as well too. So in this case, what I'm going to do is I'm just going to create some quick geometry. And we're going to tell SolidWorks where we want this to actually occur here. So as we take a look at it, before we get to the actual material and figuring it out, we're going to go ahead and put a nice little slice in here. And if I grab this, we can see that there'd be a nice seam there for me to use. There's some nice seams in the middle for us to use, and there'll be a nice seam on the back here to use as well too. So Mark, I will go ahead and jump into the ExactFlat tools.
Okay. Excellent.
And we'll get.
So what Ryan's doing now is he's just selecting surfaces to make a single surface. So he's joining all these patches, and it's going to create a surface. So he's just going to name it front. That's a good name. And go around, and you just basically select surfaces, name them, back. And as he selects the surfaces, you can see they turn transparent. So if you had surfaces, in some cases we might have a surface underneath a surface you want to select. This makes it pretty easy to do when you make everything transparent. So now once This is just about finished. There. Awesome.
Oh, I didn't type it right. There we go.
Spelled it wrong there. So now we have all our surfaces created. The next thing we're going to do is we're going to go into ExactFlat. So we're going to connect to ExactFlat. So it's going to take the SolidWorks mesh, the render mesh, and bring it into ExactFlat. And now this will allow us to select what materials we're making this the furniture out of. So if this was a leather chair or whatever fabric, you just go into the ExactFlat material manager and select the materials that you want to make the piece from. All right. So here's our material manager. We have just a sample database here. So I don't, what material are you going to use, Ryan?
Gonna go ahead and use the brush warp knitted fabric.
Ooh.
Because I like saying that.
Yeah. That's so now it's ExactFlat's taken and applied the material metrics to that. So how the material, the yaw on the left of the material, that's one thing that ExactFlat's very accurate at flattening because we actually use the material mechanics to flatten with. So here's basically on the left side, you'll see the 3D representation of the file, and on the right side, you'll see the 2D pieces. So ExactFlat's a two-step flattener. The first step is this step where it gives it a projected flat, and then we're going to optimize, which means we're actually going to go through and take the material properties and flatten it based on how that material flattens. So we're just, Ryan's just changing the mesh, doing an adaptive remesh, and now we're ready to flatten it. So go through and it's going to, you can see the status, the pattern status, and you can see actually the pattern piece is changing. And this is based on how that material flattens. So go pretty quick here. That piece is completely flat. This one's done. And these other two little guys here will go through pretty quickly.
Let me bring up the database here.
Yeah,
we can talk about where this data is coming from.
Yeah, that's another unique feature of ExactFlat. It runs on a database, a SQL database, and once you connect to the database, now you have base construction type. So if you go into these, maybe on the where it says management tools, Ryan, on the next column over, if you pick hardware types, whoops, no, the other way. Yep. What it'll do is, oh, there we go. It'll bring up different hardware types. So here we have our furniture database. We have things like buttons, Velcro straps, J-hooks, labels. So we have the information of the item, the cost of the item. You can have the vendor for the item. You can assign different colors. And it's quite easy to add a new item. If you just scroll right down to the bottom where there's a blank space, you could type in whatever new item you want, A whatever. Yes, you could put a whatever there. I had to put the laptop up to my head and see what you were writing.
Oh, sorry.
I don't have my reading glasses. Anyway, so basically as you go through, we have access to all this information, which once you tag a material, this follows it through the whole stream, all the way downstream, so and upstream. So it's a fairly unique option in ExactFlat. And these are the materials here. So if you actually, can you click on the nesting tab? So when you have material selected, such as we're doing on that chair, it has the lay rule. So how that material has to lay on the cutting table, the rotation, the tilt. It'll give the length of the roll, how much is left on the roll, what the width of the roll is. So all this information is attached to that item as soon as you click on the material, and it's pretty cool. Anyway,
all right,
and that's the physical properties. So one of the things that we can mention too is that we have the ability. So if you have a specific material that you want tested, we have labs that test our materials for us. It takes about 3 to 5 business days, and it's about $20 or $25 for a material test to be done, and then you could add that material into the database. So if you don't have the material information, we can do testing for you and get that information for you. Anyway, I think those last two pieces are pretty well flat. I mean, you could just stop that, I guess, really, and
Okay.
there. Mm.
Yeah, there's no funny bumps or anything on it, so
No.
I think we're pretty happy with it.
Yeah. So now what it's going to do is going to take the flattened pieces and put them on what we call our pattern view, and that's where you would add your seams and notches. So it's going to rebuild these pieces from that step and go into, as I said, the pattern view. One of the tools that we have is a tool called, pattern makers will understand this, walking the pattern. So we're able to match pattern pieces together. If you had a file that might be 10 or 20 pieces, you can use that tool and you can align all the pieces up, and Ryan can kind of show you that too. So
This will take a second. Sorry about this.
yeah, no. It's got to align all the edges up. So it's, what else can we talk about? I guess the other thing would be,
I don't think it's ever taken this long. This is one of those, it is a program, right?
yeah, yeah. I think
It's the last piece it's doing.
yeah, it's the last piece.
I'm telling you, it's my computer. It's messed up. I got my IT guy working on it though, so.
Oh, there we go. It's snapped out of its.
Yeah, it is those last pieces. It's drawing that geometry, trying to get it in right.
Well, it's it's 3 and 4. So it went through 3 and now it's working on the 4th piece, but it'll take a second. I'll snap out of it, but.
So as far as that testing, I've had a couple customers go through the testing, and you are right. It took about 3 days to get it back, and it takes less than 5 minutes to actually get that material in the system. So it's not some long drawn out process, which I was really pleased to see in the long run.
Yeah, and I guess like if customers do have if they do have the data, we have the ability that you can kind of, I call it hand bombing, but typing the information in yourself. Although some of the mills don't provide, I guess, all that type of specific information, so it is good to get it tested. And it's reasonable.
Definitely.
Oh, there you go.
All right, so now we're going to be updating, and I think this is where the flat's actually being generated after it's kind of figured out its geometry. Is that correct, Mark?
That's exactly it. So all the pattern people know, the flats and setting up the, there you go. So those are your pieces, all flattened.
So I'm going to move these around a little bit, and if you want to tell them what I'm working on here.
Yeah, so this is what I was saying before. It's called, we call it walking the pattern. So what you're doing is you're just kind of lining the pieces up, and you'd select an edge, and we have a tool called a find tool, and that's what Ryan's doing right now. So you can basically see how the pieces are going to line up and how they get sewn together. So if you do like Ryan's doing a 1-inch seam offset, so basically that'll allow him to actually throw a seam on there and kind of see where it's going to go when you put your notches in and whatnot. But I mean, in the old days, I mean, it's still done this way where you would actually take your 2D pieces and you eyeball where the two pieces join together, and then you put a notch and make sure it fit on the other side. In this case, because we're coming from a 3D model, we know where all the coordinates are from the 3D to the 2D, so it allows us to do walking the pattern automatically or automagically.
All right, so now that we have that in, probably the next step would go to seams.
Yeah, let's throw some seams in there. The seams are coming out of the database as well, so yeah, the 2-inch seam might be a little bit too much, but there you go. Yeah, 10 millimeters good. So as Ryan's selecting one edge, you can see the other edge is automatically being highlighted, and as he goes around the edge here, it's going to create a nice seam for us, and you can see the start and the stop of the surface. So basically, we're going to do the seam on the other side, and then the next step would be add a few notches. And as I said, all this information is stored in the database. So we have some customers that might have 20, 30 different notch types and a whole plethora of seam types. So all that information is stored in the database and is completely customizable by the user. So we're going to create a notch chain, come up from the database, ask what size notch we want. In this case, we've got a 1/4-inch V notch, and it's put 3 notches there. So you can either do it by number of notches on a part, or you can click specify a length. Oops.
There you
go. There's all the notches because they're 3.94 inches. And they all line up perfectly, so no eyeballing.
All right, and then probably we want to look at drawings too, right? We talked about drawings, so let's go ahead and turn this into a drawing. And so we'll kind of jump back into SolidWorks here for a second. And it kind of works the same way. Even though it came from a different piece of data, we still have the ability to go ahead and drop that flat in there. You can see that not only do we have the seams showing out, but we do have our notches in there as well too, and they'll be able to see those together. Along with that, we're going to want to go ahead and put some other pieces of information in. And this all depends on what you're looking to do here. So in my case, let's go ahead and we can throw in the piece table. Piece table is just going to basically give us a list of all the pieces that were in here. And we'll also see that they get a piece ID along with the piece name as well too. And the piece ID is basically going to get connected up to this particular, there we go, this particular piece. So as I tag these out, we'll see that everything kind of just conjoins together. But up here, we do have material balloons. If you are using different types of material, you do have the ability to call out the different types of material. You're not relegated to one material per part as well too. If you're using maybe some suede and you're using some leather together, then you can actually have that mixed on the single piece, and that's where the material balloon would come out a little bit nicer. If you need to talk to the people that are actually sewing it together, you can tell them what the edges are, what the notches are. If there's any hardware there, whether it's a J-hook, a snap, Velcro, you can go ahead and call that out as well too, much like an assembly inside of a 3D CAD system. Other than that, we can go ahead and get out of here. We do have the costing capability. The only other thing that we would probably want to cover here is your final outputs. And let's flip back over to the component here. And if you want to walk me through this process here, this will be under the view markers, correct?
Yeah, absolutely. So the next thing is you want to go out to your cutting table. So we're going to have our marker view set up. Ryan's got the one piece and it's ready to go to the cutter. We have ExactFlat has 2 capabilities. It has manual nesting, which means that you can just drag and drop pieces onto the marker just like that, and we have collision detection, so it'd show if you bump into something, you can't do that. And but we also have automatic nesting, and automatic nesting just creates a nest automatically for you. It takes the parameters. If we were doing 200 of these chairs, it would just throw 200 on the marker, and it would nest those, so it compact it to save as much materials as you want to let it run for. Anyway, this case we'll just hit export, and we'll export out this file. And we select our cutter. We create profiles so we can export out to any cutter, Gerber, Electra, Eastman, Autometrics, whatever cutting system you're using, and I'll just create a file that has a profile. So it's a DXF file that has a profile that would have the layer information required for that cutter or plotter, whatever you're using. So we just created this auto-generated marker and put it on our desktop, and we can show you. I guess right now it says that the part's ready to view, so we'll view the part in eDrawings, I guess.
And that's just to verify that, yeah, data was written out.
Oh, draft.
Dang it.
Draft
Yeah,
site.
sorry. I don't know why it's opening in a draft site. There's your verification. We'll just look at the verification. So eDrawings is usually what I would use. I had this one turned on for some reason. I do apologize for that. But you can see that not only the outlines there, but also your notches. So when you send that to the laser, when you send it to the cutter, whatever you're using to do that, that's all just going to come through. So
right on.
Let's get out of there. Cancel. It's the last time I let my child use my computer. That's what we'll blame that on. Okay, well, let's take a look at this, going back into here. So best practices for furniture makers. We walked through this and we did a lot of talking. There was a little bit of wait time you saw there, but that's probably worst case scenario. There was a lot of stretching that it was trying to account for, and it is accurate data as it comes through. So what we kind of walked through was created the 3D design for the hard and the soft components. We prepared all the parts for production. We didn't do the CNC, but SolidWorks does come with a 2.5 axis CNC addition already inside of it, and it's at the even at the base level of SolidWorks, it's available to you. So getting information out to a router if you are cutting wood and stuff like that. But even if you get a little bit more curvy and more 3D-ish and you're looking for more complex patterns, there are steps to get those in as well too. Once we create the patterns were pretty straightforward. We added our seams in, we put our notches in, and then we ended up just sending out that DXF to the cutter, and we got it so that it worked with the cutter automatically. And that's going to be one of those little setup things that we just kind of make sure that you're all good to go from there. We want that to be a click button solution, and that goes back to the whole linking and shrinking. The other nice thing that we have here is if we were to make any changes on the 3D model that we'd already done the patterns on, it's actually a pretty easy button, and I'll just point to it. But there is an update regimen that you can go through where it will go through and re-flatten everything back out for you and figure out if there was any changes, if there was a length change, a size change, those patterns will update again. And then once again, it's a simple process of going into the view markers and then re-exporting it back out to the cutter to get that change, get it cut out as soon as possible. Managing the changes, there's the communicate updates across the team. It doesn't take forever. It doesn't take one person to do one thing, one person to do another thing, try to communicate back and forth. The programs are actually pretty easy to use with a little bit of training. And once we get you into the program, we find out that those changes are very easy. Any one person could probably do a change, but even if they don't want to do that change, they want to communicate, it's an easy process to get the change done and have that move downstream. And really, that's that whole waste and waiting that we're getting rid of. It's not you say one thing, someone else does something else, you wait for it, then you reprocess the data, then you bring it back in, and then you find it's not right. It gets rid of that. It really does streamline the communications. The other one is you're ensuring the fit interactively. We're making sure that it fits before we even start cutting. We don't have to do a test run. We don't have to build a mock-up. In a lot of cases, we may be able to find it, especially on this chair, that after we get comfortable with the program and we know the little ins and outs of it, you can give it one try out, and next thing you know, you're fitting everything up right then and there, and it's a good product on your first prototype as opposed to doing multiple prototypes. Oops. So talked about a chair. This is may not be directly in your market, but really what we're talking about is the hard goods and the soft goods and the final melding of those together and not having to bump out of the system. Once again, that linking and shrinking of the entire process. I guess at the end of this, really what we'd like to do is there's a couple of questions that came through. It looks like there's at least one question from Nathan. I'd like to go ahead and attend that, but I do kind of want you guys to take a look at here. So Nathan said, how do you mitigate the patterning for cushions that are not directly fabric on foam? A feather wrap foam slab as a seat cushion. Would you model the crown effect by the feathers in Solidworks, or a piece of foam that gets wrapped in Dacron? Do you model the foam dimensions or the foam plus the Dacron? And this is one of those things where I'm going to kind of throw that over to Mark. Mark, did you hear the question?
Yeah, yes, I did. So basically, I'm trying to envision modeling the cushion itself. I'm very familiar with doing the engineered foam, where we're basically just taking the surfaces, and I can use an example. We did a wingback chair previously in a demonstration a couple of years ago, and what we were doing is we were extruding off from the cardboard surface that was on the inside, extruding that out and creating the cushion, and then using the surfaces of the cushion to flatten. We created our seams and everything just as we did it, just as Ryan did, and we flattened that, and it was very accurate. We were able to create those patterns quite quickly. Not familiar with modeling feather pillows, so I don't have a comment on that. I mean, I assume that would just be kind of a feathered filled pillow. Is that what I'm understanding, Ryan? Is that what Nathan's speaking
That
of?
I don't know. Nathan, could you expand upon that by any chance? Let's see, Nathan. Nathan, do you have a mic? I've turned your mic on if you want to speak real quick. Maybe Nathan doesn't have a mic.
Could be. Well,
all right. And I've run across that as well too. That question does come up periodically, is if you are putting a loose stuffing into something, how do you account for that? And I don't think I've ever had a really good answer. And I think it's more, that's where you're going back to a little bit of the tribal knowledge. Does that make sense? Okay.
Yeah. And that's, I mean, it's kind of like a free form when you're drawing a free form surface, and ExactFlat's going to flatten the surface, whatever the surface is, right? So look at the topology. I'm looking at a cushion right now, and yeah, I guess you could definitely model that and make the surfaces, and ExactFlat will flatten those surfaces. But as you said, it kind of goes back to tribal knowledge and working on pieces like that for sure.
Okay. All right.
Maybe Nathan could send us an email so we could maybe get a conversation going with him also.
Yeah, most definitely. Yep, that's kind of will too. Thanks, Nathan. I appreciate that. All right, so basically for you guys attending, there is a little bit of an appreciation bundle. And in appreciation of joining our online event, we'd like to kind of offer this to you. So right now we have on Solidworks Premium, which is the highest level of Solidworks that's going to come with all the surfacing. Well, it comes with your, it comes with routing. It comes with, what else does it come with? Really, it comes with an FEA package as well too, if you want to do stress analysis. So say you want to make sure that couch can seat that particular size person, and you can get away with your minimum amount of material, or if you just want to see if it's going to survive a 12-year-old birthday party or something, that will go ahead and give you the highest level there. And so the other thing is that along with the 50% on the Solidworks Premium, ExactFlat will have a 25% discount on it as well too. The only downside to this is you have to have this ordered by 12/31/2018. So by the end of this month, it's the only way that we'll be able to help you out on that. After that, prices are going to go back to where they are, and I would say definitely try to take, if this is something that you are of interest, it would definitely be a good time to get into it, and kind of introduce you to the DASI Solution family, is where we will definitely try to help you out and get you up and running. So it's not going to be a quick buy and thanks for buying it. We're going to make sure that you are not only purchasing the software, but you're going to be successful with the software as well too. If you want to further get into that, there is a number at the bottom of the screen. That's definitely the number to give a call, and then we will get you in contact with the correct person as well too. Is there anything that, Mark, you'd like to say about that, or does that pretty much cover the exact?
That covers everything. Very well done, Ryan. Great.
Okay. We've got a couple minutes here. We do have another question that came in from Dominic. And it says, do you also cover the process from mesh files to surface bodies? Basically working with scanned information. And, we're not going to cover it in this meeting, but can we do it? Absolutely, Dominic, we can do that. Another question we have is this webinar going to be available to see online later? It will be online. I do have it being recorded at this particular moment, and so I'll make sure that that information does go out to everybody to be able to get access to it. And we will also have it available on the DASI Solutions website under our webinars page as well too. So Wally, you will be able to get there. Sorry you lost out. Padding under compression. This is from Lewis Maven. Padding under compression is like filling a balloon that will swell outward almost equally. It requires other message that I may be able to help with. So Lewis, it sounds like you might want to get a hold of us and talk about some of your ideas. Definitely, it sounds like you might have a solution to some questions that we've had. So we will, I will go ahead and write your name down, or Lewis, if you want to go ahead and contact us, we can definitely see what we can do with you, okay? Let's see if we have any other ones. No. Okay. Still got 10 minutes left. Is there any other questions? We'll give you a minute or two. We'll go to our last page here as well too. So just in preparation here, while we wait to see if any more questions come through, looking at the design, it's fast, simple, complete. Quickly we're able to get shapes in there, easy to work with, and then when you get to the end of it, when it's complete, you've got a full body of information. You've got the 3D model, you've got the 2D model, you've got the assembly models, and everything else that's coming there. When you get to the production side of things, the CNC simulations, the fact that you can actually run your cutters inside the program and then send that information out. The pattern details, knowing how they're laying, what's laying, how they look flattened out, adding in all the little ideas, implementations that you need, your notches, whatever it may be. And then you come down to the assembly instructions as well too. How do you put those together? That's going to be good for most, for the hard goods and the soft goods. Last but not least, single design environment. You'll notice that I stayed in Solidworks the whole time unless I was showing you something. You do not have to export out. You do not have to import in. Once you get it into the Solidworks environment, you stay in the Solidworks environment and everything back and forth goes from there. You have a better cross-team communication, the ability to look at that information, to be able to make changes. With our different viewers that are out there, you can either give someone access to look at something or give them access to change something. And then ultimately, going back to what we keep on talking about, linking and shrinking the entire process, this is reduced cost and time. That's what's on everybody's radar. So, keep it in mind that once we get everything together and everything works well, it's going to be nice and streamlined, and that's what we're always shooting for, is to get it correct on the, get it most correct on the first time out, and that just gets better and better after that. I do have a thank you up here, but we did from Matthew, we did get a question. It says, does this work the same in Rhino? I'm going to throw that over to you, Mark.
Does it work the same in Rhino? Rhino is a different package. Rhino has the flattening capability. They both have the same flattening engine. The difference between the Rhino version and the Solidworks version is Solidworks has all these integrated tools, seam tools, notching tools. It has a much more extensive database. So if you're just looking at flattening things, yeah, they both flatten things. But if you're actually doing a lot of seam work, if you're creating nests, if you're drawings are important to you, then obviously the SolidWorks solution is the premier solution. I mean, I don't know if there's anything else you'd add, Ryan, but and it's parametric. I mean, that's a big difference too. I would say.
From the Rhino side of things, yeah, most definitely. This, Rhino is a great 3D modeling system, which the great thing is lots of freedom up front. Downside is if you have to make any changes, whether minor or major, a lot of different rework has to go into it. I know when I did 3D modeling, there's a lot of times where you might delete a quarter of the geometry just so that you could repatch something in. With SolidWorks being parametric, changing by numbers, changing by relationships, stuff like that, you may find out that instead of having to rework everything, I can click one number and it will cause multiple items to update correctly. And then if you get into the higher end stuff, which really concepts, not even higher end SolidWorks, just higher end concepts, you can make it so changing of a single part will have a trickle down effect and change multiple pieces of or parts. And once again, once you integrate that all together, it does work pretty well. Well, I don't have anything else left. It looks like there was a couple questions that came through. It looks like Peter was asking if there's any step-by-step tutorials for really simply understanding of flattening stuff like a cylinder shape, sheet or something. I would say at that point, ExactFlat, your website actually has quite a few movies on it. Is that correct?
Yeah, we have a YouTube channel, and I can definitely send out some links to some of our tutorials. We have a bunch of tutorials up there also. So if you want to connect with me or send us an email, send myself an email, please do. And I don't know if my email address is on one of the slides, but if not, my email address is mark.jewell, Jewell, at ExactFlat.com.
And I think we're going to be sending out a little bit of information afterwards. I'll make sure I get with our marketing person to get this information out to everyone who attended.
Excellent.
Mickey, what kind of balloon are you talking about? Like balloon animals? Hot air balloons? We had a question come through. So is there a tutorial for like animals? Oh, awesome.
Balloon animals?
Yeah. I've seen stuff. There is a stuffed animal that is out there. Now the balloon, I don't know about the balloon side of things. So once again, it is something that we can definitely talk into. So if you have an idea, definitely get a hold of us and we can see what we can do for you there. Okay. Not a problem, Mickey. Thank you. Okay. All right. Well, I appreciate everyone's time. Thank you very much. And I would just like to leave out with I hope to talk to you guys more in the future and help you become successful, more successful than you may be today.
Thanks, Ryan.
Thank you, Mark. I appreciate it. Thank you very much.
Bye.